Whoa! It's very bright, isn't it? Actually, it's over a million times brighter than daylight. This is what we call synchrotron radiation. Or to be more precise, synchrotron light is an intense electromagnetic wave generated by the loss of electron energy due to the changing of its direction. Its wavelength ranges over 4 wavelengths, namely infrared, visible light, ultraviolet, and X-ray, which is beneficial for many science fields, but especially for material science. And I'm going to explain you how this works. So, this is the machine producing synchrotron radiation. It composes with 6 parts. So, start with the first part, electron gun. It is the source of electrons. And the second part, linear accelerator. It accelerates electrons and sends them into the third part, the booster synchrotron. The booster synchrotron keeps electrons traveling near the speed of light and send them to the fourth part, the storage ring, which has bending magnet, and those bending magnets producing synchrotron radiation and send them into the fifth part, the beamline. The beamline is taken into use in other applications. The sixth part, the experimental lab, used to control all the machine.
Okay, next let's talk about the storage ring. As this is one of the important parts of this machine and also play the majority role in the synchrotron radiation. Okay, along the circular part of the storage ring will consist of the bending magnets, and these bending magnets, some part of them are called wigger. The wigger will cause the electron moving in the zigzag part. While the electron is moving in the zigzag part, it will radiate the EM waves, and this bunch of EM wave will be sent to the experiment hatch. Next, we have to go deeply in detail about how the EMF was produced. As you can see, the electron that is moving along the circular part, it has the centripetal acceleration, and this will cause the phenomenon of the accelerating charge. And the accelerating charge will create the EM waves. However, this phenomenon is similar to the radio antenna. The difference is that the accelerating charge in this phenomenon is faster than the radio antenna, and the speed of this accelerating charge is approaching to the speed of light. So we have to consider about some relativistic effects. And we also have to consider about the relativistic lemma formula to explain how synchrotron radiation produced, and also to find the actual frequencies of the rays.
Now we all know what synchrotron is, but what are the benefits of them actually? Well, let's find out. Synchrotron radiation are mainly focused on analytic and imaging microcomponents, so it allows scientists to do experiments to find the molecular properties. But what are advantages of synchrotron radiation over outer radiation, such as laser? Well, first, synchrotron radiation has very high energy to penetrate deeper in a matter. Second, its small wavelength allows scientists to investigate a very tiny feature such as bond in molecules. Third, synchrotron beams are used in very specific experiments. The last one is, synchrotron beam can be made to flash at very high frequency, so it allows us to follow chemical reaction in a very short period of time.
จบแล้ว